gives me great pleasure to introduce our speaker, Saurash Cupta. And he works at a company called Wonder Workshop. And just to give you the tie-in, our own Rohan has worked with Wonder Workshop so there has been some cross-pollination there. So with no further ado, here you go.
Thanks, Ben.
Thank you.
Hey guys, I'm Saurash Cupta. I'm one of the founders and CTO of Wonder Workshop. I'm here with Vikas and Philip. It's our first time here. Thanks for having us here. I'm here to talk about us, what we are doing, what's the mission we are on. We'll talk about the robots themselves, and at the end, we'll have some demos. So who are we? So we're a startup based in San Mateo. We're a small group of engineers, designers, parents, with one mission. How do we make programming accessible to every child? And we're talking children as young as 5. So this is who we are. We're a learning to code and play platform for kids 5 and up. So whenever I say that, the first question that comes up is, why are we doing this? Why programming? I think that's probably something I don't have to preach to this audience, but still, I have slides, so I'll go through it. So it's an increasingly common topic these days. You've heard it from a lot of people. Eric Schmidt mentioned how important programming is. There's been a lot of buzz recently about how US is falling behind the rest of the world as far as programming goes. It's a very important thing, but still 9 out of 10 schools in the US do not offer any programming classes. There's been a lot of efforts recently to try and fix this. Even Obama, towards the end of the year, put in an effort to encourage schools and kids to take up programming and become creators, not consumers. So we're trying to tackle this problem in our own way, try to see if we can make programming accessible to kids in their homes, make it more appealing, make it a lot more interesting. Did you have a question? Wayne? So why programming? So that kids can make sense of the world. Technology already plays a big part in everything we do. It's only growing, and programming is the key to make sure that every child can understand what's happening around them. Make sure that they can take part in the creation process and not just be blind consumers of technology. But coding is just a tool. So what does it mean for an 8-year-old? Our goal is not to make an army of programmers. An 8-year-old isn't going to come take a job somewhere doing coding.
Well,
so
if it's Rohan, you don't know.
Yeah, so this is an average 8-year-old, obviously not Rohan. So actually, I know Wayne mentioned at the start about Rohan. He's been involved with us. We also have Ted and everyone else from Logic, and they have helped us a lot along the way. So thank you to them for getting us where we are. So an average 8-year-old, how can we make them interested in this? What can be the most amazing payoff for an 8-year-old? Maybe it's robots. So that's where our robots come in, and I want to just take a moment to introduce you to these robots. This is Dash, and the smaller one here is Dot. So the obvious benefits of having robots are they're tangible, they're collaborative, they're fun. Programming is a very abstract concept, and it's really hard to take an abstract concept like that to a 5-year-old. This is where robots come in. We make it a lot more real, we make it a lot more tangible, and we make it a lot more fun. Our vision is to have every child bring robots to life with the code they write. So all of you have seen a lot of robot toys, a lot of robot products out there. They all come pre-programmed. They're really fun. But again, it's something that someone else has done, and as a child you can play with it. Our goal is, can we make this the platform where kids can create their own play, their own fun with these robots? So how we got there? We were founded in 2012, so it's been just over 2 years. We built our first prototype in 2013, and that's where the logic, and we got help from a lot of people. We ran a crowdfunding campaign in October of 2013, which did fairly well. We raised about 1.5 million in a month. We got our Series A funding in February of 2014, and we started shipping the robots in November of last year. So we've only been shipping the robots for about 5 months. We shipped about 25,000 robots in our very first month. And in a month, we got these robots to the White House. So for those who are active on my Facebook feed, you can see photos of Obama and a few others playing with these robots in the White House.
Is he involved about that?
Sorry?
I better don't say that.
Do you have one of those pictures with a blank stare? Because that would be priceless. That's Obama staring at the screen with a blank.
And not knowing what to do.
I'm sure that's not the case, but it's just.
No, we don't have that. That actually would be really cool. So since then, we have been shipping to parents and children in their houses. We also started shipping to schools. We did a pilot program with 25 schools where we took this to teachers, to students, to prove that this works, that we can actually teach programming using this, and it's fun for them. Since then, we have expanded to 300 schools. We are available on our website, on Amazon, and starting from next week, we'll be available in the Apple Store. We have a bunch of apps out there, and there's a next set which goes live in June. All right, hope you can hear me. And the robots have been to places other than the White House. So this is my favorite TV show, Big Bang. And for those who caught the episode last week, we had people there playing with the robots. I love that one. So here's our crowdfunding video.
Writing and arithmetic. Introducing Bo and Yana. They're toy robots, but there's so much more than that. They're a learning and storytelling platform that makes computer programming accessible and fun. Meet Bo. Bo can be programmed to do an unlimited number of things, from basic movement, to object detection, to complex sequences of instructions. And this is Yana. Yana can detect when it is being moved, allowing children to invoke characters. These robots can detect each other, and accessories can be added to give them special abilities.
They teach the basics of computer science in one of the best ways possible. Problem solving through hands-on playtime. And our research shows that that is one of the best ways for children to learn.
Bo and Yana are designed to be programmed by children using our touch interface with music, animation, and stories, as well as existing languages like Scratch and Blockly.
We try to get them to watch less TV, push them to learn new things, but it wasn't until these robots came out of the box that our kids just got so absorbed.
Programming applies to and is used by virtually every field. Art, architecture, medicine, law. Learning to program is really learning problem solving. Taking something big and seemingly incomprehensible, breaking it down and building up a solution. And this concept really applies to virtually anything.
Learning to program isn't only to become a computer programmer. We want to help shape our future innovators, our future thinkers, our future leaders. And the future is today.
So that's a crowdfunding video. I'm sure you recognize a few faces from that video. So thanks for being a part of our video. So this was about the company, about who we are. I do want to take some time to get a bit more into details of what these robots are, what are we trying to do more on the technical side, and then we'll do demos. So our main goal with these robots is how do we build this robotic platform that's really accessible? And what we're trying to do here is we want to solve the harder problems and the more mundane problems in robotics and enable developers, users, kids to focus on the fun experience. There's a lot of things that go with building a robot, as obviously all of you know. a lot of them get repeated over and over again. Can we get it down to a point where we can make it possible for someone as young as 5 to use those robots to do really interesting things? And get to a point where even adults who have no robotic experience can use it and put it in their apps or in other play experiences that they have envisioned. So here's a very quick overview of our platform. Probably too much on the slide, but I want to spend a bit of time here and talk about what we have done. So we have these 2 robots, and we plan to build more of these. They all share a common robotics core. That is what we feel is the essence of what a robot needs to do, a robot like ours. That's the core which handles all the aspects of communication. So we use Bluetooth, Smart. That's the interface that works with your tablets, iOS, Android, Mac, and a few other platforms. That's the core which does all of robot management, so firmware upgrades, upgrading sounds. That's the core which has a robot personality. So that's the essence of what the robot needs to do. People have been trying to use robotics for education for more than 50 years now. It started with the old turtle robots, which you can program to do stuff. And they're all really fun, they're all appealing. But one thing which we feel is essential to really make it succeed is to make the robot likable, to make it have a personality that kids can relate to. So it's no longer just taking a robot and making it go around in a square. Can you take the robot and make it do really, really interesting things? So that's where the personality module comes in. It's something that the robot comes configured with, but our goal is the personality is something the user will build and develop on his own. And then we have the API. So that's the interface for the robot to talk out to the external world, where you can send commands to the robot, where you can look at all the sensors. Essentially, be able to do everything that you want to do on the robot, but from a second device. Then on the other side of the spectrum, we have devices, tablets, Macs, which can talk to the robot. So again, we have these different layers, a base communication layer, which knows how to talk Bluetooth, or could be any other communication protocol. A cross-platform API, which does all the things that you would normally want to do with the robot. So how do you make the robot move? How do you make it play a sound? How do you make the robot navigate a room? How do the sensors work? So everything which you want to do with the sensors and the actuators of the robot. And then over that, we have the API. So we expose an Android API, an iOS API. It's an open API that people can use to build applications. It's the same API that we are using to build applications that come with our robots, but others can take it and use it to build interesting stuff. And we integrate that with a lot of platforms. So we integrate with Unity, with Maya. That makes it really easy for both for us and for others to build custom animations for the robots, or to come up with custom screens. We have a JavaScript API, and I try to demo that towards the end of the presentation, that you can use to build your own state machine or build your own program if you're proficient in coding. So all of that combines to give us this developer API or ecosystem. So it's all our apps on iOS and Android, our JavaScript API, our iOS and Android API. So all of that combined to build an ecosystem and a platform which scales, which gets you what we want. So these robots, if you leave them unattended for a while, they tend to go to sleep. So that's what you're hearing. So what does this enable? Actually, and feel free to ask questions. This is towards the end of my presentation, but would love any questions you guys have. What does this platform enable? As a user, you can focus on the experience. Any apps which you build on this platform will work for all existing and future robots. So these 2 robots, or any robots we build in the future, will all share the same code, the same infrastructure. Any applications that we write and others write will just work for the next gen. And that's a huge win. I mean, quite often we see multiple generations of products, and every time you have to start from scratch, both for us and for our users. hopefully this platform will avoid that issue. We can build new robots, others can build new robots with sensors and actuators which can plug in easily with the system. So we can have a mechanism where apps can identify what's connected, what are the sensors, what are the actuators, and make it work seamlessly. Tools like Maya and Unity make it simple to add compelling animations. So the way we do a lot of our animations on the robots is in Maya. We also have programming-based interfaces. So the goal is you can come up with really appealing personalities and behaviors on the robot. You get access to powerful usage and diagnostic data. So we have a bunch of sensors on these robots, which are streaming their data live to an iPad or Android device. And it's a lot of information. If you think of this as a toy, it's the first time that a toy has information on what is the child doing with this robot or with this product. If he's moving it around by hand, if he's throwing it, if he's picking it up, those are all patterns that we and developers can track and detect and use to figure out what is it that kids do with this product and how can we make it more appealing and add more experiences. So yeah, this is what I had in terms of introduction to the robots. Again, feel free to ask me any questions you guys have. If not, we'll go to demos. Yep.
Yeah, could you just quickly list what actuators and sensors it comes with?
Sure. So the question was what actuators and sensors it comes with. So we're going to do this on this. This is a main robot called Dash. It comes with 2 wheel motors. Comes with a head which can pan and tilt, as you guys can see. It has a speaker. You can use that speaker to play synthesized sounds. It comes with a bunch of sounds, but you can add your own sounds. All of that is wireless. In terms of connection, it's Bluetooth LE. So we have a port, but that port is only for charging. Everything you do on the robot is done wirelessly. We have a bunch of lights. So the eye is individual LEDs, which can be controlled, the chest, the ears. In terms of sensors, there are 3 distant sensors, 2 in the front, 1 in the back. It has encoders, so it can do accurate wheel motion. It has accelerometers, gyros. It has a potentiometer, so you can accurately position the head, both pan and tilt. It has 3 microphones, so you can use that to detect sound and also triangulate where sound is coming from. So as a child or as an adult, I can make the robot turn around and look at me if I'm speaking. And it has buttons. And it has beacons. So all around the neck of the robot, we have IR transmitters. And in the eye, we have a stereo IR receiver. So one robot can look around and detect other robots. So that lets us do sort of fun multi-robot scenarios where you can have one robot chase a second robot. And actually, I'll give you a demo of this in Blockly, but you can, as a child, you can write a program where the bigger robot is going around the room searching for the smaller robot.
No camera?
It doesn't have a camera, no. So that was one of our goals with this product was to make it accessible and both for cost and complexity reasons, we chose not to put a camera in this version. Sorry, Rohan?
Yeah, do you guys have a way of storing the program on the robot itself so that if you don't have an iPad, you can still start up the robot and run your program?
Yeah, so the short answer is yes. So right now, what we have done with our applications, so our applications are still evolving. The 4 applications we have right now, they are mostly designed for playing with an iPad Android device. So they don't let you store a program on the robot. We're going to talk about an application very soon, which will let you do that. So we have our own state machine running on the robot that you can control, and you can add programs, you can add animations, you can add sound, all wirelessly.
So what is the processor that's on the robot?
So we have 3 processors on the robot, but they're all Cortex ARM M0s. So it's not a lot of horsepower. There is a lot of I/O, there's a lot of sensors, so we need multiple processors to handle that. But it's not running Linux. It's running a very basic real-time operating system, and it's in total about 24 kilobytes of RAM. So again, that was one of our goals. We wanted this to be a platform, but we didn't want to start off with a huge processor. We wanted to compact a lot of features, a lot of sensors, a lot of actuators in an affordable price point. So right now, as far as the price goes, so this robot retails for $169, and from everything we know, it's probably one of the most powerful products in this price point. Yep.
My son was doing similar things many years ago. He called it one robot, and a little bit more primitive, and he had a very nice language for it. So you could program loops and all kinds of functions. And he sold it to many schools, and the kids had lots of fun. It's nice to watch the kids playing with it. One of the problems seems to be the teachers. It's new to them, and it's not on their schedule, it's not on their plan. So that seems to be the biggest obstacle.
Yep. Actually, that's a very good point. So you're right. So we work a lot with teachers, and we know the kind of issues we have in schools. So there are two things we are doing to address those. It's a very important problem that we have to solve. One, we're trying as much as possible to be a product that can work without adult supervision, without teachers. So there's a lot of scaffolding that we're building into our applications. How can we take a 6 to a 12-year-old sitting in their house, maybe they have a parent helping them, or maybe they don't, but walk them through the process of understanding everything that we want. It's a very hard problem. It's something that we are working with a lot of teachers, a lot of students on how to solve it. The other thing that we are doing is we're working a lot with schools. So we have a lot of teachers who are signed up in almost like a beta program or an ambassador program, where we work with them, and it's a two-way transfer. We work with them to make sure they have a curriculum, they have the resources available to be able to take this and effectively teach it, and we learn a lot from them. We learn a lot from their experiences, what they have done so far. Their experiences with kids tells us a lot about their product. Like, these are the kind of things they would want us to do on the robot or in the applications. So it works out really well. It's a hard problem. It's not something we can solve overnight. One thing I will say is it's a problem that's slowly reducing. I think as schools are getting more awareness, we are seeing teachers who have computer science backgrounds. They are getting into education now. They now have access to a lot more resources. So it's a real problem, but something that hopefully can be fixed.
It looked like you, with that thing, you write programs and then put them on there and it runs them. Is there anything where you can like run it in real time and do controls?
Yep, so the question was, can we operate this in real time? So actually the way the robots are designed, and I should have touched on that back in my slide, the predominant mode of interaction is real time. Everything that you do on the iPad is running in real time. So the goal of this product is not to write a piece of code, compile it, transfer it to the robot and have it run there. The brains of the robot are on the iPad. Everything is running real time on the iPad. And it's really important. So for example, if you write a piece of blocky code or any language of code on your robot on the Mac, it's actually running in real time. So you can see what's happening on the screen. As you make changes, they will take effect in real time. All that the robot is doing is it's receiving instructions from the tablet and it's sending back sensor information. So in real-time mode, the state machine for the robot is running on the iPad.
So my question is more like, can you drive it like you would drive a remote control car? It sounds like that would be, I mean, maybe you could type out fast enough to have it turn left and right.
Yes, so the question is, can you drive it like a remote control car? In fact, that's the very first application. So our goal with this product is for a child, it shouldn't feel like it's an educational product out there to teach them programming. For them, it should feel like here's a fun toy. So the first thing that a 6-year-old will do is he'll just open the app, open up the remote control, and drive it around. So we want to build that connection first. It's fun. It tells them what they're doing, that they are in control, and only later will they actually get to real programming.
Do you use any other media for teaching how to use it and what to use it for?
Yeah, so the question is,
I'm sorry? Or what to play, what games to play.
So that's a very important question for us, both for our mission and as a company. How do we keep our users engaged? How do we give them the right play ideas, the right tool sets to play? So we do a lot on that. One thing which works a lot is we send a bi-weekly to a monthly newsletter, which has a lot of play ideas on what are the kind of programs you can build with this robot, what are the kind of attachments you can add, the kind of creations you can do. We also organize workshops for really interested people to come in and get some play ideas. And then the work we do with teachers helps a lot. So students in their classrooms, they have access to a lot of resources on how to play and program these robots.
What's your favorite game with the robot?
So one of my favorite games, probably the most favorite game, is something that we created about a week ago. So there's a bunch of people in our office. So we have access. I mean, in our office, people have access to the API, obviously. So they took the robot and they created a racing game out of a few different robots. And Philip is one of the guys who created it, and he's actually setting it up back there. So once I'm done with this presentation, I would like all of you to come and play with it. It's a lot of fun.
Why is he looking around?
So the question is, why is he looking around? So one of the things that we wanted to do is, especially for a child, give them the feeling it's not a lifeless thing. It's something they can identify with. It's something they would want to play with, so almost like a companion. So the robot comes with a default basic personality where when you turn him around and you're not really doing anything, he acts bored, he looks around, he can yawn sometimes, do a few little animations, and if you really don't play with him, he'll go off to sleep.
So it's not stimulus-based?
This particular interaction is not stimulus-based. It's something you could do. You can program it so that based on the sensor responses, it can run those animations or do something like that.
Can it get air if it goes off the ramp? Does it go fast enough?
So the top speed of this robot is about a meter a second. It can get a little bit of air. It's also fairly heavy. So it's, I mean, they're pretty sturdy. I mean, we've tried doing it with ramps and all. So they won't break, but it's not really going to get a lot of air.
So where do you see this going in the future? What other types of robots or other attachments or extensions?
So it's a platform, and there are many things we want to do with this. One of our main focus areas is how do we build up on the software platform. So there's a lot you can do purely in software. We add more experiences, add more different ways of programming it. We have a few accessories that come with the robot. There's a xylophone accessory that you saw in the crowdfunding video that you can use to play music. We have accessories like pusher bars. There's a cell phone mount that you can mount your cell phone in, and then that can be used to add video or camera to the product. We're also working on a couple of new accessories which are going to come by the end of the year. So again, sort of more active stuff that the robot can do. So it can fling balls around. It can play sports. So we're going to build accessories that help you do that. Then we're working on the next gen of these robots. So there are many different ways in which we can add functionality to these robots, and we're exploring all of those. So right now it's a $169 robot. We can add a camera on it, make it slightly more expensive but a lot more powerful. So that's one direction we were looking at. We're also considering possibly an even more reduced cost version, something that gets it even more accessible. The good thing is, since we have this platform up and running, that was the hardest part. It's actually really easy for us now to add features or take things away and build it into a complete family of products. Yep.
Two quick questions. First, what's the battery life like on that, with like an extended or continual session? And also, are there sort of predefined or like sample behaviors or routines that are accessible to users and they like get them to the app and things like that?
Yes. So the question is, let's answer the second question first. Are there predefined routines? Yes, definitely. In fact, a lot of our users will probably spend a lot of time just playing with the predefined stuff. They need that scaffolding to understand what to do with the product and to have fun. And really building your own stuff is almost like an advanced to intermediate concept that comes later. In terms of battery life, it has a pretty good battery. If the robot is driving around and turning its head non-stop, it can last for 90 minutes. So in pretty much any play pattern you have, the robot will last for many hours. And the robot charges to full battery capacity in somewhere between an hour and a half to 2 hours. So you get, even if you charge it for 20 minutes, you get a lot of battery life.
So to go to market, what kind of safety and liability hurdles did you have to get over?
I mean, a lot. It's a long, complex process to get a product for kids out in the market. There's a huge list of certifications that you have to follow in terms of safety, reliability. Obviously, nothing on the robot is in any way harmful to a child. We don't have any lead in the product or mercury or anything else. We have to do a lot of reliability testing. So as a 5-year-old, it's going to be very common to take this robot and drop it on the ground or smash it on the head or throw it, bang it against the wall. So we're going through a lot of testing to make sure it doesn't break it as much as possible. We have seen that you can drop a robot from 3 feet, 6 feet, and it works pretty well. You guys can try it out after the demo. But the even more important thing is even from really tall heights, right? If you throw it from a building, you want to make sure it does. Even if it breaks in a way that's not dangerous to kids. So there's no small parts. There's nothing that comes out or can be harmful. And then on the application side, we have to follow a lot of compliance. We have to make sure everything in our software is COPA compliant. So if kids are using to create content, we have to make sure it's done in a way that's safe. So parents can be involved as it's been required. There's a bunch of compliance that we have to follow on that side too.
How many apps are there, like similar to Scratch community?
So how many apps are there similar to Scratch community? So in terms of how many apps do we have right now on the product, we have 4 apps in the market available on both iOS and Android. One of them is Blockly. It's an app we wrote with Google. Blockly is, I'm sure a lot of you are familiar with that. It's a Scratch-like language developed by Google. So they work with us on porting that language to iPad, to Android, to a touch device. So that's the only language we have right now to work on touch devices. As far as programming the robot goes, you can program the robot using our API in Objective-C or Java or JavaScript.
My question is, how many user-created apps share in the community? Like my son is, download a lot of apps.
So the question is how many user-created apps we have right now. The answer is 0. When we just came out, we started shipping the product about 3 months ago. Our API went live about a month ago, but right now it's still in private beta. So there are about 150 people who have access to the API right now. We're working with them on finalizing the API and making it available for release to everyone. Actually, let me take it back. So we have 0 apps on iOS. We have 2 apps on Android. So releasing an app on iOS is obviously a long and complex process, and not a lot of people want to go through it. We have a couple of power users who have released apps on Android. Our goal is to work with people who are really interested in that and seeing how we can help them bring out more apps on both iOS and Android.
sorry for this remark, but kids should not run programs, they should program themselves.
Yeah, I think that makes complete sense. And it's a kind of a hard thing to do.
So with Blockly, could kids share apps that they wrote with other kids?
So it's something we're working towards. Right now, no. Partly this is work we have to do. Partly it's making sure we are COPPA compliant. So there are lots of strict rules on how sharing works. So in the current version of Blockly that we have, you can write programs, you can't share them. Our goal is by the end of the year we'll have a platform, a sharing platform where you can upload programs, browse, and download what others have done.
I'm not quite understand. Well, there's a Scratch community where some that like in few hours share a lot and download a lot. So what do you say? Some regulation Blockly cannot do that?
So for one, we don't use Scratch on our robots. We use Blockly. So Blockly is slightly different than Scratch. And right now, Blockly works through an iOS or Android device. So right now on the touch platform for iOS and Android, there is no way to share programs. There is a way to do it on a website. I believe there's a way to share Blockly programs on a website, but that's not something we have integrated on touch yet.
Yeah, I just wanted to comment on that because I've had some experience with the federal regulations, and whenever you have anybody under 18 with the ability to share with someone else under the age of 18 online, it's nigh impossible. And the reason is because kids somehow love to embed things like the F word and whatnot into apps, and it just violates federal regulations. So don't really expect this anytime in the future. The things that you can download now, I'm sure they require you to say I'm 18 plus, and most kids lie anyway, but there's minimal protections.
Yeah, I think it's a good point. I hope it's not impossible. I mean, I know it's really hard. We're hoping there are ways around this. We hope to have safeguards in place. We're also working on a potential system where parents get involved. So a child can create programs, but there's some process of parent approval before they upload it. So I agree, it's a really hard problem. I hope there would be a solution.
What's the manufacturing cost?
It costs us about $1,000 each. And then we pay the difference.
Good answer. Are both products bundled together?
So right now we sell the main, so this is our main robot Dash. We sell it for $169. You can buy the two together as a combo pack. I believe it's $229. So our second robot Dot is meant more as a companion robot or as an accessory. We don't sell that by itself.
Is there a cliff sensor on the robot so it can avoid having to survive a 6-foot fall?
No, there isn't. Maybe it's something you can help us put on the next version. Yeah, I think we should do the. Oh, actually, no. So I have a bunch of iPads and robots with our apps. So probably the best way to play with this is I can bring the iPads and the robots here, and we'd love you guys to come and play with them. At the back of the room, Philip also has my favorite game, so feel free to go over there and try it out. And the three of us are available, so feel free to come and ask us any questions. Yeah. Thank you guys.
Thank you very much. Please come up and play with these robots. They look seriously cool. Okay, so what's going to happen now is we go into random access where we just talk. And I'm going to be bringing the box which has the badges and putting it on a chair right here. And when you walk out, please drop their badge in and then go straight out the door to the parking lot. Okay? Thank you very much.